Okay, so for the second part, what we want to do is be able to predict the effects of parameters on the graphs of square root functions. So in other words, we want to understand how a graph is going to change based on some sort of or type of transformation. All right, so you can read this introduction part. It's just basically saying that we're going to look at how the transformations that are done here affect the graph of f of x equals the square root of x. Okay. So for part A, it says predict the effect on the parameter h on the graph of g of x equals the square root of x minus h for each function. All right. So first thing we need to do is understand what type of transformation it is. Okay, so if you look at A, okay, this is page 290, problem A, towards the bottom of the page. Okay, notice that where the minus 2 is, the minus 2 is inside of the square root, right? That indicates that it's an inside operation. I want to take a moment to kind of review a little bit. The function that we last talked about was the rational function. The rational function or the parent rational function is 1 divided by x. Okay. If I apply this same inside subtraction by 2 to that function, then I would end up with the function 1 divided, so I'll call this g of x, but I'd end up with the function 1 divided by x minus 2. This is inside subtraction because the subtraction is happening to where the x is at. And that's how you tell whether something is an inside or an outside operation. Where is the subtraction or addition or multiplication happening? In this case, it's happening in the denominator. Where the x is located, that's inside. Regardless of whether we're talking about the rational parent function or we're talking about this square root parent function, the effect of this transformation is going to be the same. And what effect is that? Well, this is where we would want to look at the transformations document and find this sort of transformation. Okay, and I believe what we'd be looking at here for this particular type of transformation is row 2. Inside subtraction. Okay, so inside subtraction, in particular, inside subtraction by 2 just happens to match up with what we're looking at. And as you can see here, the effect on the graph is it's going to translate the graph 2 units to the right. All right, now then, if it was inside subtraction by 3, it would move it 3 to the right, 4 to the right, 5 to the right, and so on and so forth. Okay, but inside subtraction is going to translate the function right however many units that subtraction is by. Okay, so we could go ahead and fill that in here for that. So that's going to be a so what is this called? What is this kind of transformation called? Well, there's 2 common names for it. One is shift, so we could say the graph is shifted, or is a shift of the graph, or the maybe more technical term is translation. Okay, we're not changing its size, we're not changing its shape, we're only changing where it's located, and that is referred to as a shift or a translation. So it's a translation of f of x. F of x is just the square root of x. So it's a shift of that graph 2 units to the right, or in other words, right 2 units. When you look at B, we see that in this case we have inside addition. Well, you go back to our document and look at row 1, and we can see that inside addition is going to move the graph to the left. In this case, it's going to be left 2 units. And so we'd want to say here that the graph is going to translate left 2 units. So just trying to save me a little time here. These next ones, I'll go ahead and say that those are going to be translations as well. Translations, translations, translations. Okay, so these are all translations because they're all either inside or outside addition or subtraction, and those types of transformations transformations will be translations. All right, and so here we've got going left 2 units. Okay, now then on B, you see that the addition and subtraction is now outside of the square root sign. And therefore, we're going to be looking at an outside operation, outside addition on A, and outside addition on B. A quick look at the transformations document, lines 3 and 4, and we're going to see that outside addition is going to move it up. Outside subtraction is going to move it down. Okay, so we would want to go ahead and say that on for that one. So back to the document there. Sorry about that. So up for outside addition, down for outside subtraction. Okay. Let's go ahead and switch our focus to D at this time. And I've got D up here. All right. So we need to do the same thing. We're still predicting effects. We're still saying what kind of effect it is going to be on the parent function, the square root of x. Okay, but notice on this one, look at A, B, C, and D. This is now on page 591, problem D. Look at where these numbers are located. We can see that they're inside of the square root side. So these are inside operation. Well, what operation? Well, what's happening between the numbers and the variable x? What operation? Well, the answer to that would be multiplication. So these are inside multiplication type of transformations. So the first one is inside multiplication by a half. Okay, so what's that effect going to be? Okay, so we're going to need to go down here now to lines 8, 9, or rows 8, 9, and 10 to see the effect of inside multiplication. For this first problem, we have inside multiplication by a half. And we can see that that will horizontally stretch the graph by a factor of 2. So it's going to become wider by a factor of 2. All right. So we can say it's going to be horizontally stretch. The graph is a horizontally stretch of the graph of f of x by a factor of 2. I guess I really just need to say horizontally. Doesn't make sense with horizontally. So the graph is a horizontal stretch of the graph of f of x by a factor of 2. The next one is inside multiplication by 2. So you could see that inside multiplication by 2, that's line 8. That's going to compress it by a factor of a half. Okay, and it's going to be horizontal again. A point to make here is that anytime you have an inside operation, whether it's inside addition, subtraction, or multiplication, the effect is going to be a horizontal effect. With inside addition, subtraction, that moves it to the left or to the right. Well, that's a horizontal movement. And inside multiplication is going to give you a horizontal compression or stretch. In this case, it's going to be a compression because the multiplication, the inside multiplication, is by a number that is greater than 1. And when that is the case, then you get a compression by a factor of 1 divided by that number. In this case, that's a 2. So that's going to be by a factor of 1 over 2. Okay, so this generalization. So if it was 3, then it'd be by a third. It'd be a compression by a factor of a third, and so on and so on. Okay, so we want to say again, it's going to be a horizontal. This is the graph is a horizontal. Compression of the graph by a factor of 1/2. Okay, now then what's different about C and D? Well, in this case, you would notice that the numbers are negative. Well, how does that affect the graph? Well, then we need to now go to line number 10 here, and we're actually going to get a combination of 2 of these different types of effects. One of them is we're going to get the effect of inside multiplication by -1. And on C, we're also going to get the effect of inside multiplication by 1/2. So not only are we going to get a reflection across the x-axis, across the y-axis, y-axis, we're also going to get a horizontal stretch again by a factor of 2. So we've got both of those effects happening here because that number that we're multiplying by is negative. And that's going to give us that reflection across the y-axis. Okay, so again, we're going to have a horizontal transformation. It'll be a stretch by a factor of 2 once again. But again, we're also going to get a reflection across the what axis? Across the y-axis. Okay, so you should make sure you're filling out your page 591 as we go through these. All right, and the last one here, now we've got inside multiplication by a -2. So we're going to get a horizontal effect once again because it's an inside operation. This time, just like it was for B, when we had inside multiplication by 2, inside multiplication by -2 is still going to give us that same horizontal compression by a factor of 1/2. But because the 2 is negative, we also get the reflection across the y-axis. Okay, so for these types of problems, what we want to do is find the transformed reference points. So down here at the bottom, these are the reference points they're referring to, 0, 0, and 1, 1 in this case. Those 2 points here are marked on the graph. What we want to do is figure out when we apply this transformation to this parent function, then how will these 2 points be affected? Okay, what will they change to? Okay, what will be the coordinates of those 2 points after this transformation? Okay, but we also want to describe the domain and range of this function. Okay, so first thing that we have to do is we're going to start with the domain. Now, what we have to realize about square roots when we're only using real numbers is that we cannot take the square root of a negative number. The reason why is because there is not a negative number. There is not a negative number that would multiply by itself that would equal -9. 9. There's not a number that multiplies by itself that equals negative 9. You say, well, wait a minute, what about negative 3? Well, negative 3 times negative 3 is positive 9, not negative 9. So if you were to try to type something like that in the calculator, you're going to get an error, a non-real answer type of an error. So what that means is that this part that is underneath the square root sign, this negative 1/2 times x minus 2, that has to be greater than or equal to 0. It cannot be negative because we would end up with an error, okay, or something that just can't be done. So this is what we need to solve to find the domain. Okay, whatever this, whatever x is here going to be, that's going to be our domain. So to solve this, it says here we want to multiply both sides by negative 2. So I'll actually show here the multiplication of both sides by negative 2. And what that's going to do is that's going to cancel out this multiplication by negative 1/2. Because negative 2 times negative 1/2 is equal to 1. And we can therefore consider those as canceling each other out. Well, 0 times negative 2 is still 0. 0 times any number is 0. However, one thing we do have to remember is that when we are solving an inequality problem and we are multiplying or dividing by a negative number on both sides of the inequality, then that means we have to flip the sign around and make it now a less than or equal to sign. Okay, then we'd add both sides by 2. We'd add 2 on both sides to get the x by itself. And we would end up with x's less than or equal to 2. 0 plus 2 would be 2. Okay, so if x's are less than or equal to 2, then this number underneath the square root sign is going to be either 0 or positive. So that is our domain. Expressing that in set notation, we can say x is such that the x's are less than or equal to 2. Okay, so you set what's underneath to find the domain, you set what's underneath the square root sign greater than or equal to 0, solve for x. That's your domain. X cannot be any number that is bigger than 2. Okay, to find the range, all this mess inside of the square root sign is not going to affect the range. Okay, so if you think about this parent function, when we apply the transformations that's inside of the square root, that actually has no effect on the range. It doesn't affect what the y values are going to be. The only thing that's going to affect what the y values are going to be is going to be the +1. Because the +1 is going to move everything, shift everything up 1 unit. Okay, and so therefore, what they're saying here is that, well, what they say first is that the square root function is non-negative, so this has to be greater or equal to 0 again. Okay, and then they add 1 on both sides. Well, then if I add 1 here and I add 1 here, okay, then I'm going to get, on the left side, I'm going to get this negative square root of negative 1/2 times x minus 2 plus 1. Well, what they say that this expression on the left here, what is that? That's just g of x. That's just g of x. Okay? That's what all this right here is what's on the left side after we added 1 to both sides. Well, 0 plus 1 is 1. Well, if this is g of x, well, that's the same thing as y. So this is really telling us what our range is going to be. It's going to be y such that the y's, which are the g of x's, are greater than or equal to 1. Okay? Now then we want to see how these 2 points are going to be transformed. Okay? So let's start with the point 0, 0. All right, we want to do these in order. We want to do the multiplication effect and then the subtraction effect. Okay? So when we transform this, when we reflect it across the y-axis, which is what the negative is going to do here, that doesn't change its point at all. It's still going to be at 0, 0. It also isn't going to, the negative, or the 1/2 isn't going to affect it as far as stretching it. Remember, n sign multiplication by -1/2 is going to be a reflection across the y-axis and a horizontal stretch. But those two effects on this 0, 0, because that's the center of this, or where the function starts, that's not going to affect it at all. So that all that's just going to still be at 0, 0, the -1/2. Now the subtraction by 2, that will move it right 2 units. And the addition, outside addition by 1, will move it up 1 unit. So that point will shift to 2, 1. Okay? Now let's look at the point 1, 1. So, first thing I would want to consider is how the reflection, or how the negative is going to affect it. That's going to flip it across the y-axis. It'll move it to the point -1, 1. Well, then the multiplication by 1/2 is going to stretch it by a factor of 2. So now then that's going to then move it to the point, I'm going to stretch it by a factor of 2. So that means I'll double what that is going to be. And so that'll move it over to a -2. Then we're going to subtract inside subtraction by 2. That will move it right 2 units. And then you have the outside addition by 1, which will move it up 1 unit. So that point, after all those transformations are performed, is going to translate the function to the point 2, 0. And the other one was translated to the point 2, 1. Okay, and so that transform function will look something a little like this. It's stretched horizontally. It's been reflected as well. Okay, and it's been moved up 1. And it's been moved to the right 2.